Hello everyone, welcome back to another lesson. Today's learning goal is we will determine the effects on the graph of a parent function f of x equals x squared when f of x is replaced by f of x plus k, f of x, f of k times x, and f of x plus k for specific values of k. Specifically, we're going to be talking about the addition and subtraction really, but addition and subtraction of k. So we're going to be talking about this one and this one. So, if f of x equals x squared, then the shift of f of x plus d shifts the parabola vertically. And when d is positive and we add d, we shift up, and then when d is positive and we subtract d, the parabola moves down. Okay. So, Lorenzo translated f of x to create m of x as shown. Use the graph to answer a and b. Write a function to represent m of x. Well, here we're shifting it down. This is x squared, and we're shifting it down 1, 2, 3, 4, 5, 6, 7. So therefore, we have m of x equals f of x minus 7. So it says compare the features of m of x and f of x in the table, and then circle the features on the graph that a vertical shift will change. So the vertex changes, obviously, because f of x is 0, 0, m of x is 0, negative 7. So that changes. Okay. And then the domain, well, the domain for any quadratic in standard form is all real numbers, and so we'll say the same for if it is shifted down. Range, well, the range will change, right? Because the original one is y is greater than or equal to 0. Now it's y is greater than or equal to negative 7. The axis of symmetry, that does not change because it's still x equals 0. The parent function f of x equals x squared is shown to the right. In a through b, observe how transforming the function using f of x minus c affects the graph of f of x. So here we are going to change it by doing x minus 2. So essentially we're doing f of x minus 2 equals p of x. Okay, and p of x is this now. Okay, and sketch the graph to the right and describe how the equation and the graph compare to f of x. Go ahead and do that on your own. So what you should have found is that this is the graph of p of x, and what we did was we shifted it twice to the right. So the subtraction of 2 from the input value, and the graph shifts the graph is shifted 2 units to the right. To predict how the graph of r of x equals x plus 4 would relate to f of x, and use your prediction. Check your prediction using a graphing calculator and sketch the graph of r of x on the grid above. Go ahead and try that on your own. What you should have graphed is something like this in the purple, and found that the adding 4 to the inputs shifts it to the left by 4. Okay, so the equation adds 4 to the inputs, and the graph is shifted 4 units to the left. So if we do x minus c in our inputs, this shifts the parabola horizontally. And if we do x minus c and c is positive, well, that shifts it to the right. So the subtraction shifts it to the right, the addition shifts it to the left. We're going to complete the table and compare the features of f of x and p of x. So p of x is the red one right here. Okay, and then circle the features that will that a horizontal shift will change. Well, the vertex changes from 0, 0 to 2, 0. So that changes. The domain still stays the same because anything in standard form, any quadratic in standard form is all real numbers. The range, well, that stays the same as well because it still has a minimum of 0. The axis of symmetry does change, though. The axis of symmetry changes from x equals 0 to x equals 2. The graph of f of x equals x squared was transformed to create a through d, and use the functions to answer 4 through 6. Describe each transformation in your own words. So here, we're subtracting 2.5 from f of x, which means we're going to shift down 2.5 units. Here we're subtracting 8 in our inputs, which means we're going to go to the right 8 spots. Go ahead and try C and D out on your own. You should have found that C is a horizontal shift of 2.5 units and that D is a vertical shift of 8 units down. Which cards have functions with the same axis of symmetry as f of x? Well, remember that vertical changes do not change the symmetry, axis of symmetry, so therefore it's going to be A and D. Which ones have the same range as f of x? Well, the range only changes if it's going vertically as well. Okay, so horizontal ones don't change the range, so therefore it's going to be B and C. Which ones have the same vertex of f of x? Well, none of them do, because they all change the vertex. Haley graphed one of the functions below. Which function did Haley graph? So this is a shift to the right 8, so therefore that is going to be B. And here's a picture of my dog.